it's so good to see so many of you here tonight. Once again, we're having a League of Women Voters meeting, Roseville area, in April, because on this coming Monday, it's Earth Day. And so we're having our environmental theme program tonight. And it is a delight to welcome Dr. Kenneth Blumenfeld as our speaker. Ken is a senior climatologist for the State Climatology Office. What's climatology? I'm sure we'll know by the end of the evening. He focuses on climate change science, extreme weather events, and aligning the state's agencies, communities, and citizens with up-to-date, accurate information about Minnesota's changing climate. Often, we read Ken's comments in the newspaper and hear him quoted on the radio. I've heard him twice recently. After his presentation, there will be a time for questions. And just please ask one question. If there's time at the end, we'll have time for more questions. So, we are experiencing changes in the weather. We just have. So, Ken, what's the big deal? Welcome, Ken Blumenfeld.
Thank you, Ann. Everyone hear me okay? Yeah. Good to be here. Thank you, Pastor. It's nice to be in Prince of Peace again. I feel like Ann and I are old friends now. About 5 years ago, I got a note from my friend Mark Seeley. He said, "Kenny, I'm really sick. Can you cover for me? I've got a luncheon talk with Prince of Peace Church." And it was the older kids, the big kids, lifelong learning group, right? And I thought, well, I was working in the private sector at the time, and I needed a good long lunch, so I took it and came up here and tried to put something together in a pinch, and I think we had a good time. And then I believe it was last fall, the former pastor had actually contacted me, so I went out to, I believe it's Forest Lake, where he is now, and met with his group there, and it's good to be here, and it's good to be with this organization, with the League of Women Voters. If I am at all off my game, I apologize. The last 3 months have been, we had been referring to them as the meteorological or climatological Super Bowl, but that didn't seem right. And then we thought, okay, no, it's the climatological Final Four. And then we realized it kept going. It became the climatological Olympics. And I think maybe the World Cup, right? The whole tournament to the World Cup. We've had quite an experience over the last few months. And I'm going to just tell you guys a bit about what I do and what we know about our climate. We'll have a real nice, easy conversation here. You'll see some graphs. I'll try and walk you through what they mean. We'll talk about what's changing and what's not. We'll talk about what counts as the climate, what counts as weather, what counts as climate change, and what doesn't. So let's just kind of move forward here. I started my current position within the DNR it was 2015. And half of my job is basically doing this. Coming to speak with organizations about what's going on with Minnesota's climate. Now, you might recognize that a lot of groups just want information, and I expect that's what's going on here. We want information, we want to make sure we have a good understanding. Maybe we want to heckle the guy who's talking, who knows? But most people just want information. However, I also work with a lot of state agencies and county agencies and communities, and people have to make decisions about resources in Minnesota that we manage, whether they're roads, whether they're the rivers and the watersheds, or perhaps it's communities or forests, any of a number of things. And people really want to know how this climate change that they've heard about, how that might affect the resources that they work with and manage. And I have to say, I'm not surprised. Pardon me, I'm going to move around a little bit. I'm not surprised that people have had some of the confusion that they've had, because when I started this position, it was, and I'm going to find a comfortable spot, I swear. When I started this position, I knew a bit about climate change because I'm a climatologist and I was relatively up to date, but I hadn't drilled down to figure out what did it actually mean for Minnesota. I had some hunches and some suspicions because I had been going through the data for a while, but as I dove in, and then I started hearing from people, I realized that people had wildly different perceptions of what climate change means here in Minnesota. And I had to very quickly understand why. And one is, well, our climate is different from the rest of the country and the rest of the world. And as the global climate has changed, as the global temperatures have risen, our symptoms have been different from other parts of the country and other parts of the world. But when you read a story, if you're not a scientist, if you're reading a news story or hearing something on the radio and it has to do with climate or climate change, you're probably only hearing a story that was so big and so important that it rose to the level of making it onto CNN or Fox News or NPR or whatever news source you're using. And there's a really good chance it didn't pertain to where you live. And so it shouldn't be surprising that people had assumed that all of the stories that we were hearing about in different parts of the world, they must get at parts of the climate that must be true here. And that's actually not the case. So we have our own unique symptoms and our own unique expression of the climate change that differs from what you'd find in California or Nevada or Great Britain or China or India or anywhere in the southern hemisphere for that matter. And it's important to remember, of course, we're globally connected. So anybody who studied Earth system sciences would know that they'd tell you, well, of course, what's happening in the climate over the ocean absolutely affects birds and migration patterns here. But again, many of my audiences, they're dealing with resources right here. They're dealing with the Cottonwood River or the Mississippi or the northern Minnesota forests. And they want to know what's happening to those forests because of the weather and the climate changes here. Point number 2, observations and projections. They're two different branches of climate science that work together to give us a whole picture. And that picture is what's happened historically, where are we right now in terms of what's been changing, and where are we going? These are two different branches of the climate science. So observations deal with measurement, and they deal with usually kind of concrete numbers. We know what the temperature was today, and we therefore know the average temperature for the last year, and in many places we know the average temperature for the last 100 years or more. And the same is true with precipitation and snowfall and other measured variables. The benefit is we get a number. The drawback is we can't ask our thermometer what the temperature is going to be in 40 years. And even if we're good with statistics, we can't figure it out. We can't just use the past to tell us what's going to happen in the future, because there are things that are going to happen in the future that we can't see just by looking at the past. Projections offer the benefit of giving us insight into the future. They require very sophisticated, four-dimensional modeling of the atmosphere. The atmosphere is a complicated fluid. Its laws are still being understood, but they're generally governed by the same laws of thermodynamics and fluid mechanics that govern other fluids. And so, as you might expect, projections using computer models give us insights, but they can't give us specific details. But these two branches One is not superior to the other. They're doing different things. We can't measure the future right now. So the best thing we can do is build models of our atmosphere and try and estimate what's going to happen in the future. And for the past, we can't begrudge the fact that we didn't have computer modeling to figure out all the things happening in between, but at least we have measurements. Sometimes people like to say, well, they don't trust the models because they're not as good as measurements, or, measurements have human error, whereas computer models are just computer programs and must be objective. These aren't at battle with one another. And if you're ever in a conversation where one person dismisses one branch of science in favor of the other, it's good to remember they work together. They're part of the same solution set. They're just different careers within one field. Point number 3, Anne mentioned it might describe what climatology is. So I've got a game for you. You just talk back to me here. Say someone's moving here from, before we do that, how many of you grew up in Minnesota? I always do this wrong. How many didn't grow up in Minnesota? Okay, if you didn't grow up in Minnesota, where'd you grow up? Nebraska. Ohio. Where in Ohio?
Toledo.
Okay, my mother's from Youngstown, so. So some other.
Rhode Island.
Rhode Island, okay. Iowa. Wisconsin.
Another Ohio.
Ohio, where in Ohio?
Just outside Cleveland.
Very good. Sandusky?
No, close. Lakewood.
Other way, okay. So, if someone was moving here from, say, Arkansas, and they just said, help me understand the climate here. Real short. I'm also trying to understand the people, the environment, the economy. So they don't have time for an entire lecture. What would you tell them? Let's start with winter. How would you describe winter in a few words? Cold?
Snow.
Cold and?
Snowy.
Cold and snowy. Okay. Now, how would you describe summer? Hot and humid. Okay. Let's just go with hot and humid. So we've just described the climate of Minnesota. Cold and snowy winters, hot and humid summers. I can agree with that. But we also know not every winter is as cold and snowy as we expect. Some are more so. Not every summer is as hot and humid as we expect. Some summers are more so, right? Now we're describing variations or variability. It's a big word that gets thrown around a lot, but this is what it means. It means that you have your expectation, and then you have also sort of expected variations around that expectation. Right? I mean, we all know we have a friend who's a generally really nice person, but we know that he's not in the same mood every single day. We also expect variations around that expectation. And the variability of our climate that tells us, well, we get dry periods and we get wet periods and we get hot periods and we get cold periods. Anyone who grew up here knows we've always had that. You can read the pioneer notes, you can read the old Native American winter counts from the Dakota tribes, you can go through any historical artifact, you can see it if you look through the paleoclimatological record where they look at fossils or lake pollens or trees, and we know that we've always had variations in our climate. So I would say your climate, climatology, is the study and the recognition of sort of the expected condition of the weather and the expected and reasonable variations around that expected condition. That's a very wordy definition, but we have, in our climate, we have some trends. Now, that's another term that gets thrown around. And when we talk about trends, especially in the age of social media, trend seems to me things that are becoming popular, right? So, what's trending now? We're not talking about what's trending now. We're talking about a statistical trend, something that fits onto a statistical trend line that is expressed through basic linear algebra or geometry, just using the slope function, y equals ax plus b. But we don't need to get into equations. A trend is in climatology when we have a statistically verifiable change in some kind of weather variable. So let's say in the case of Minnesota, we know we're getting warmer. We have trends towards warmer conditions. There's statistical trends showing us that our climate has gotten warmer. At the same time, we still have variations. So sometimes we're colder than we would expect, sometimes we're warmer than we'd expect, even as we have these trends towards warmer conditions. The two things, trends and variability, are not at odds with each other. They actually work together. They're part of our climate, and they're even part of our climate as it changes. Therefore, it's nonsensical to say, well, it was cold last week, so this climate change stuff is garbage. It's also nonsensical to say, well, it was hot last summer, so therefore we can prove climate change. We need more than that to establish a trend. We need more than 1 year or 1 week. We need, multiple instances of the kind of weather that we're looking at to show some kind of a trend. And the last piece is, apparently my ear is larger than the average person. The last piece is we all need to stay up to date. It's my job to stay up to date, so maybe it's more important for me than for a lot of people in this room. But this is a science. It's a scientific field. And science is defined by discovery and breakthrough. And that means that as people are learning more about this field, they are publishing their discoveries in peer-reviewed journals, and they're putting them out into the world, and that slowly is changing the body of what we know about this phenomenon. So in 5 years, it'll be at least a little bit different. Maybe my talking points will be the same, but some of the details will be different, or maybe I will have had to change one talking point in some small way. I don't expect huge changes in 5 years in terms of what we know about Minnesota, but there might be pretty big changes within 5 years about what we know about the US or about the globe at large. So that's the preamble. Let's get down to business. In Minnesota, and this whole conversation is to help you have a good conversation yourself about Minnesota's climate. We've got 3 certifiable changes, 3 statistical changes, 3 trends, and that's it. It's real easy, and they're interrelated. We're getting warmer and wetter. That's trend number 1. It's actually almost happened it's been synchronized. Minnesota's becoming warmer, and it's becoming wetter. And that relates to the next point, number 2. The way that we're getting warmer is mostly through rising of our lowest temperatures, through increasing the temperatures during the coldest times of year, and also the coldest times of day. So low temperatures, daily low temperatures are tending to rise. Winter temperatures are tending to rise, but especially winter low temperatures are tending to rise. And especially wintertime low temperatures during the coldest outbreaks of the year. Those have been hit the hardest by the changing climate. So it's lowest temperatures that are increasing the fastest. Think of it as we're getting warmer, but really we're getting a lot less cold. That's the right way, that's a good way to think of it. We are getting warm, and if you want another analogy for that, imagine that you've got a room that you're trying to keep warm. You want to increase the temperature a couple degrees. Well, you have 2 options. You could turn the heat off, right? You could put another log in the fire, however you do that. But you could also go after the drafts, right? You could prevent the cold air from coming in. And it's really, we're sort of following that ladder model currently. We're getting warmer, but it's really because we're dampening that cold air. The third interrelated piece here is really how we're getting wetter. And that's extreme precipitation. Heavy rain, heavy snow, they're both becoming more common, especially heavy rain. And the heaviest of those rainfall and precipitation events are becoming heavier. Now, this is not every single year, everywhere in Minnesota, but it's a trend towards having more heavy rainfall and precipitation events and towards having them be heavier and a little bit larger than they were historically. When we talk about the changing climate, we're really asking a very basic question. Has the thing that we're looking at changed with respect to what we expected historically or what we observed historically? So it's a very easy test. I mean, without going into the statistics of it, the test is simple. Establish normal historical ranges for whatever we're looking at. And then just look to see if what we're looking at is now outside of those historical ranges. So, are the annual temperatures outside of historical ranges? Yes. Are the winter temperatures outside of historical ranges? Yes, yes, yes. Are the summer high temperatures outside of historical ranges? No, they are not. Is rainfall outside of historical ranges? Yes. Snowfall, for the most part. How about snowpack? There's less. How about drought? There's less, or it's at least within historical ranges. So we can actually go through each of these things, and the three things that are exhibiting outside of range behavior are right up here. And then we've got some important things that aren't. They're not. These are important hazards. They're part of our climate. They're part of our variability, but we have not yet witnessed a change in their behavior. Not yet. And those are hot days, including warm nights, heat waves, however you want to look at it, even if we throw in relative humidity and look at the heat index, we don't see yet in Minnesota any increase in heat waves. Similarly, because we're getting so wet, we have not seen an increase in drought. Drought, we're very sensitive. We're sensitive to all of the things on this page. And they're going to remain part of our climate. But for now, they are not showing signs of getting worse. So drought is the second one, and then the tornadoes and severe convective storms like straight line winds and hail, those are not becoming more frequent or higher intensity or more widespread or longer duration or anything like that currently. However, for heat waves, it's very clear from the science that we should expect that to change within a few decades. We don't know exactly when it will begin. That's the problem with projections, is you can't be exact. But there's really good evidence that at some point in the next few decades, we would start seeing more summertime heat and heat waves. And then along with that, drought isn't quite as likely to increase, but it is at least appearing possible that as we get to more summertime heat, we would evaporate more water, and then you'd get into at least intermediate or flash drought type situations. With tornadoes, hail, and high winds from thunderstorms, we really have a scientific split jury here, where when we run some of the models, they show more of these kinds of storms, and about equal number of models show fewer storms, and the theoretical science behind them is a little bit unclear. And so all I can say is we should expect them to be part of our climate, but they're not necessarily getting worse. All right, so let's talk about the first one, how we're getting warmer and wetter. This is a graph, and before everybody says good night, I think we can handle this. I think we can do it, okay? Just think of it like this. Every dot is a year in Minnesota. We don't know what year, okay? If the dot, where the dot is placed from left to right, tells you how cold to warm that year was, okay? Where the dot is placed from bottom to top tells you how dry to wet that year was. So up here in the upper right quadrant of this graph, we have warm and wet years. Down here in the lower left, we have cool and dry years. And the middle of the graph, which shows you 26 inches of precipitation and 40 degrees Fahrenheit, these are actually the 20th century averages for the state of Minnesota. Very handy. It's like, it's within 1/100th of a degree and a 2/100th of an inch for both of those. So we got lucky. What you see is visually symmetrical. It looks like it's centered nicely along those 20th century averages. I did play a trick though. When I started doing this, I said, well, I'm going to withhold 30 years because 30 years is a good number in climatology. It makes us confident that what we're showing has some meaning. So I withheld the last 30 years. So this only goes from 1895 through 1986. Of course, now I have 32 years that I can show you. But watch the difference as we go to the next 32 years. It's no longer centered on the middle of that graph. And if you remember, what that means is we've actually jumped into warmer and wetter conditions. In fact, of these 32 years, only this one, I'm not sure which one it is, but only 1 year out of 32 was cool and dry by 20th century standards. The other 31 were some combination of warm and or wet. 2016, not quite the very wettest on record, you see a couple higher, and not quite the very warmest on record, you see a few that are warmer. But it was the combined warmest and wettest year on record in Minnesota. And look at what it beat out for that dubious distinction. A bunch of other years from that recent 32-year period. All of the warmest and wettest combined years on record, going back to 1895, were in the last 30-some years. We've shifted to a warmer and wetter regime in Minnesota. I'm not going to run this animation since I'm running it off of my computer, and ironically, it breaks my computer every time. But what it shows, it's really interesting. This is average precipitation across Minnesota in running 30-year averages. And we just started at the beginning of the record, and we run it right through 2017. And you see the average precipitation across the state is 26 inches here. And to the right of this line, to the southeast of it, the average precipitation goes up. And as you get into those red colors to the left of that line, the average precipitation goes down. With the range at the beginning of 32 inches in the far southeast to 20 inches in the far northwest. What you would see this do is this line would lurch southeastward with the droughts of the 1920s and 30s, the Dust Bowl years. And then once that stops, it would return to its current position, and then in the last few decades, it migrates rapidly northwestward across into the northwestern third or quarter or so of Minnesota. And at the same time, these dark blue colors really deepen because we're importing a wetter climate from the southeast. We're importing wetter conditions, and you can see, you can visualize it when it's animated. And I work in the DNR, and our office is just part of a large hydrology unit where people measure rivers and stream levels and the discharge from rivers. And hydrologists had noticed, and this is just one of many examples, that something seemed to change in the early 1980s. We went from, rivers started behaving differently. And I think people are pretty aware of some of the discussions about land use practices in rural Minnesota. And I don't have a position on that particular discussion. Like this group, I am apolitical. My job is not political. My job is just to give people information about the climate. But we had to be good climatologists and point out that if the hydrologists noticed the change around 1982 or 83, we had to look at what changed in terms of the climate in between 1982 and 83. And we looked at all the years, this is Lamberton, Minnesota, southwest Minnesota, from 1962 through 1982. We compared the annual precipitation. And then in the blue dots, we just looked at all the years going from 2000, or from 1983 right up through last summer. And if you look at the average precipitation in these orange dots versus these blue dots, it's almost as if you're looking at two different cities. There's a sharp change. using statistical tests. These groups are different by every possible measure. They're not the same at all. The difference in precipitation between these two periods is that the average year plucked from this group, this more recent group, has 3.5 inches more rain than the average year plucked from this group. And that's even if we include this one, which some people would argue we shouldn't even do because it's such an outlier, but we'll keep it in there just to keep it fair. 3.5 inches. Well, most people don't think of, okay, what's 3.5 inches of rain? Go like this. It's about this much. Okay? It's about this much from my thumb to my, I don't know. I don't have a ruler built into my hand, but I'd say this is about 3.5 inches. Now, put that much water down on the ground. Let it cover your feet. It'll go up, slightly above your ankles for most people. If you're standing barefoot on the ground, of course. All right, now take that amount of water and send it 1 mile, let cover the ground, 1 mile that direction, and 1 mile that direction with that depth of water. Now it's a square mile with 3.5 inches of water. That gives you about 60 million gallons of water. 60 million additional gallons of water per square mile that the sky is making available in recent years that it was not making available in the prior years. We have, this particular watershed has over 1,000 square miles. So it's actually 60 billion gallons of water that a typical year is producing in that watershed that it wasn't producing previously. Now, I'm not a hydrologist or a soil physicist, so I can't tell you exactly where the water goes, exactly how it gets to the river versus going into the ground. I can't tell you what happens if there's tile drainage or not. I can only tell you that there's more water coming out of the sky. This number is very similar to the statewide average. And in fact, in the Twin Cities area and in parts of southeastern Minnesota, it's even higher. And looking at the same general region, what we're seeing in Minnesota is we're in the wettest decade on record for the southeastern 2/3 or so of Minnesota, including this area that basically, if you follow my pointer, this is a map of Minnesota, from above the shaded area right up to within 50 miles of the North Shore. Everything southeast of that line is in the wettest 1 to 3 decades on record. And in most of that area, it's the wettest decade on record, and we have records going back over 100 years. And we don't know the entire climate of Minnesota beyond that, but we know that since we've had population increase, this is the wettest we've been. It's also the warmest we've been. And we can take all of our long-standing climate stations that have 100 years of record. These are volunteer sites. They're manned by human observers who just go out faithfully every morning and make an observation and send their observations to the National Weather Service. And when we ask these 39, we can just sort of do a survey for each of these stations that has 100 years of record. We can then go back into the record and say, okay, for each year, how many days were there with 1 inch of precipitation? And then just add up the total for each of those 39 stations for each year. And your eyes will tell you the story. Try and fold the right side of that graph over the left side. They're not symmetrical because there's more 1 inch rains falling in Minnesota now. Again, we did not change the number of observers. We're only changing the number of 1 inch rainfalls. By the way, this is not a technology issue. We've used the exact same very primitive technology for measuring rain. The rain falls into a cylinder or a bucket, and someone measures it, often with a stick. I mean, this is a calibrated stick, but it's the same technology that it was 100 years ago. And the 1 inch rains have increased by about 20% in Minnesota, so the frequency. Doesn't mean that every single year, you can see the variations from year to year. It does not mean that every single year has, 2% or 0.2% more than the year before. It means the trend over time is for 20% more of these types of rainfall events, precipitation events. Now, 1 inch of rain is not a big deal, usually. It is, I guess, if it's been winter and you have frozen ground and the water can't go anywhere, and it's a pretty big deal if it's already been soaked, your ground is already saturated, then maybe you'll get some water in your basement. But in general, an inch of rain is just the entry level of heavy rain. It's not in and of itself a flood or a disaster. But we can move up, we'll go up. On the left here, we have 2-inch rainfalls. So we're doing the same thing. How many 2-inch days with 2 inches of rain were there at these long-term stations in Minnesota? And you can do the same thing, but now the difference is more like 40%. Kind of depends on the method you use, but there's more in the second part of this record than in the first part of this record, clearly. Now 2-inch rains, you're getting faster runoff, you're getting the water starting to rise in streams, you're going to have some ponding of water at low-level intersections. If it's been wet, you're certainly going to have basement water in those vulnerable basements. And on the right, we have 3-inch rainfalls, which have increased in frequency by 65% in Minnesota. Again, it's not every single year. You can see that, right? You see that some years we'll find one. Look at these years. They're not that big a deal down here. But look at what they're surrounded by. Years where the frequency were about as high as we've ever observed. Now, 3 inches of rain is where you'll start to see flood advisories and flash flood warnings coming out of the National Weather Service, generally, because in Minnesota, most of our rain comes from thunderstorms. So if you're getting 3 inches of rain in a day, there's a really good chance that you actually got 3 inches of rain in a couple hours, or a few hours. And that means water pouring down steep hills, streams rising out of their banks, intersections that are low-lying are flooding, roads that are low-lying might have standing water in them. You're going to have large sections of impassable road until the water drains. Water in basements for sure at that point, if they're susceptible basements. So we're seeing increases in those types of rain. We can get to 4-inch rains. You see the same thing. Now, let's be honest here and admit that this big year in 2016 is off of the trend line that you would otherwise draw with your eyes, right? You wouldn't predict, going from here to here, that this is the next stop. So this was probably, we want to give credit to both the trend and the variability, but 2016 did have more 4-inch rains than any other 2 years combined. And we've seen this general tendency towards more heavy rain. And we can ask those same 39 stations one other question. We can say, well, what was the biggest rain anywhere in the state among those 39 stations? And we see something interesting. If we look at this most years, after we get past this dry period in the 1920s and 30s, most years recently seem to be behaved kind of like they'd always been in terms of the heaviest rain of the year. I said most years because I withheld some years. There they are. It's still true. Most years, look at the bottom of the graph, or look at the middle. Most years, the heaviest rainfall in Minnesota is like it's always been. But some years, with increasing frequency, the heaviest rainfall in Minnesota is like we've never seen. And if we visualize it a little differently, those of you who like statistics could say, well, the variability is definitely increasing. So sure, some years, the heaviest rain in Minnesota, it's growing a little bit. It's increasing by about 13%. And it's coming up a little bit at the bottom, but for the most part, most years are just like they've always been, but we're getting these wild swings towards heavy rain that's increasingly outside of our experiences historically. In 2007, we had a rainfall that I don't think, in southeast Minnesota, I don't think anyone who worked in climatology or hydrology or meteorology thought we'd ever see, not in our lifetime. 15-inch one-day rainfall in Hoka, Minnesota, equivalent to over a 1,000-year storm based on the recent statistics. Nobody saw that. I mean, there's no way you could even plan for that. And it's not to say, well, so the result is you've got a nice field like this. This is Moose Lake in 2012. And then there's the after. I always caution that these are clearly different days. They got the kids off the field. You don't have to worry about their safety. Or you have a before and an after in Duluth. Brewery Creek. It's not to say, it would be the wrong impression to say that this is happening everywhere, every year, it's coming to a town near you. That's not the correct takeaway from this. The correct takeaway is that these rare events are becoming less rare. These kinds of scenes are becoming a bit more frequent. So maybe instead of seeing them from one location each summer, it's 2 locations. Or maybe instead of, the biggest event in the state being 7 inches of rain, maybe it's 8.5. It's not that every place is flooding and, we need to build an ark currently. But it is that these scenes are becoming more common, and these are very expensive scenes, and these scenes cause a lot of hardship. And there's just a recent story in the New York Times about how Duluth is becoming might become a climate haven. And interesting because this is Duluth. They got their hands full. I was just at a resiliency conference there. They do have their hands full. But when you put it all into perspective, remember these are our climate symptoms, and they're actually a lot better than some other people's, some other areas. And it depends on what you mean by better. When we look into the future, the models that help us project climates of the future tell us, take your biggest rainfall of the year. In Minneapolis, in the Twin Cities, it's generally 2 inches or so. All right? Usually we get one of those in a typical year. In a really busy year, really active year, we might have 3 or 4 days with 2 inches of rain. But the average is that the heaviest rain of the year is 2.25 inches. And when we get to the middle of this century, the projections tell us, well, instead of having one of those days on average, you're going to have 2. You get an extra day with kind of A+ level rain. Does not mean that the 10-inch rains are going to increase where everyone gets 1 day of those per year. It just means that take your sort of top rainfall and add an extra day of that kind of rain to your summer, in general, around Minnesota. Meanwhile, the most notable change that actually does apply everywhere in Minnesota is the change that we're seeing in wintertime. This is just a table of numbers, and I know people love looking at tables of numbers, but what it shows you is the annual or the decade by decade trend in temperature going back to 1895 for winter versus summer. Back to 1895, winter was warming about 3 times faster than summer. So an average warming rate of about 0.4 degrees Fahrenheit per decade. But we actually know, looking at local data, regional data, national data, global data, data over the oceans and over land masses, that things really started ramping up in 1970. That's where most of the change that we're talking about today, that's where most of it began. Right around 1970, give or take a few years, depending on where you're looking, and depending on what you're looking at. And look at our changes in temperature since 1970. Winter is now warming at a rate of over 1 degree Fahrenheit per decade. Summer is warming at the same rate that it was over the long term. And because we get a new data point every year as the most recent year ends, the differences in these rates change a little bit. Sometimes winter's warming 12 times faster than summer, sometimes it's warming 9 times faster than summer. I just say, hey, winter's warming way faster than summer. And we see that most in our low temperatures. Wintertime low temperatures. So think of your daily low temperatures during winter. We're going to average them around the state of Minnesota. And over the long term, we see this increase of about 4, almost 5, almost 0.5 degree Fahrenheit per decade. But you can see each dot tells you how much variation there is around that trend line. And look up here. In recent decades, wintertime lows in Minnesota are not every year, but frequently, what would have previously been the very warmest on record. This was a cold winter, wasn't it? We just got through it. There it is. I've highlighted it for you. Now, if you look left, you'll see how common winters like this used to be. It was only cold by very modern standards. This was not grandparent cold. And some of the results of that, we experience longer growing seasons. These bars are just counting the number of days per year by decade, where the temperature remains entirely above freezing. Well, if the temperatures are above freezing, then growing things, at least they won't die, they won't freeze to death. Plants, flowers and whatnot, weeds, invasives. They won't be harmed as long as the temperature is above freezing. This is a really good station out in western Minnesota. It's Milan, not Milan. You don't go to Milan and say it's good to be in Milan. But it's rural, and there's a farmstead that's been observing the weather for over 100 years. And they've had 3 generations of observers, and it's one of the best data sets in the entire country. So we use this whenever possible because, one, it's good to show some of the high-quality rural sites, and 2, it doesn't have the contamination of an urban heat island like Minneapolis has. And what this shows is a huge uptick in the number of days. I mean, 30 additional days, 25 to 30 additional days, entirely above freezing this decade compared to historical times. Let me make sure I have 20 days, okay? But 20 additional days where the temperature stays entirely above freezing. The growing season is not just getting longer, that is the time between the last freeze of spring and the first freeze of fall. Not only is that lengthening, but then there's an increasing number of days outside of the growing season, after the